Okay, so we're going to start today in chapter 9. We'll look at what are called the alkynes. The alkynes. Okay? Remember, the alkyne has a triple bond, one or more triple bonds in the molecule. Okay? So let's get introduced to alkynes by learning how to name them. Okay? So how do we name alkynes? Okay? The ending here always gives you the indication of the name. So these will end with Y and E. So let's look at some of these. By looking at these alkynes. Okay? They're very simple to name once you know how to name alkanes. Okay? The 2-carbon triple bond, that comes from ethane, but since we have the triple bond, we put Y and E there so we get ethyne. Ethyne. This also is what's called acetylene. Does anybody know where acetylene is used?
Cutting torch.
A blowtorch, that's right. That's what you're using with acetylene. This one here, what would be the name of that molecule? Three carbons. Propyne. Propyne. Okay. What about 4 carbons? Okay. So we get butane. But if you look, when we get to 4 carbons, you can have 2 isomers of butane. The triple bond in the middle or on the end. So now we have to use what? Numbers. Okay, so I got to tell you where the triple bond begins on this one. At 2, on this one, begins at 1. So starting at 4 carbons, I've got to start using numbers to tell you where the triple bond is located. Okay? The triple bond also carries some good priority with it. If I have a branch or a substituent, like a chloro group, okay? The triple bond has priority. So we start numbering like that, just like we did with the double bond. So here we would have 5 chloro, 1 hexane. Okay. So you can see we name these things just like we did alkenes. So if you're good at naming alkenes, you'll be good at naming alkynes. Okay? Same kind of rule holds if you had say 2 triple bonds. Okay? So here, I number at the end closest to the first triple bond. So I would have a 1, 3, pentadiene. Okay? Just like if those were double bonds, that would have been 1, 3, pentadiene. Any questions on naming alkynes? Pretty straightforward, aren't they? Okay. Let's look at a little more challenging one. Let's suppose we had this kind of molecule. Okay. So here we have both a triple bond and a double bond. Okay. So here I have to ask which one is going to get priority. Okay. Which do you think gets priority? Well, you didn't know the answer, did you? You were just guessing. And you guessed wrong. Okay? So the double bond gets priority. So the double gets priority over the triple. So what end am I going to number from? The left, even though on the right, I would get a 1 here. Okay. So how do we name this thing? Well, we name the double bond first, and then the triple bond second. Okay? So if we name the double bond first, that double bond begins on carbon 2. So we have 2, and then hept is the word for 7. Then the triple bond begins on 6. Sorry about that there. You get 2 heptin, 6 ine. Okay? So the 2 tells me where the double bond is. Note I dropped the E off for the alkene. And then the 6 tells me where the triple bond begins, here. Okay. Any questions on that? That's probably the trickiest part when you have a double and a triple bond in the molecule. Okay, so let's move on here. Okay. Let's look at some properties of the triple bond. Okay, the first property is that of the geometry. Okay? So when you see a triple bond, let's just put it in a molecule like that. Remember the hybridization of those carbons? SP. So the geometry here was linear. Okay? So those two atoms fell on a straight line. So that's a little review there. Let's look at a second property. And that's the property of acidity. And we'll be talking about this for a little while. Okay, so make sure you follow along. Okay? So here, let's look at this molecule. Note that we have the triple bond on the end, and one of the carbons has a hydrogen. Okay? If we remove that hydrogen, we end up getting this conjugate base here, like that. That conjugate base is what's called the acetylide ion. The acetylide ion. Okay? So remember, for this acid to be acidic, this conjugate base must be somewhat stable. Remember that? Well, this lone pair here is on an sp carbon. Okay? If I compared that to something like this, look at these lone pairs, where this top one would be sp3, sp2. So if I compare those, as I go down this way, I get more S character. Okay? See that? This one is a half S, 50% S. This is 1/3 S. This is 1/4 S. Okay? Remember the shape of the S orbital is this here, where you have the nucleus right in the middle. So the S orbital is the orbital that's closest to the nucleus. So the more S character I have, the closer this lone pair can be to the nucleus, which does what? Stabilizes it. And so it gets more stable as I get more S character. So out of the three, this acetylide ion is the most stable. And so that makes this hydrogen somewhat acidic. It has a pKa of about 25. Not super acidic. Remember, a strong acid's like HCl -7. Water was 15. Water's not that acidic. So this thing's not super acidic, but it's a lot more acidic than the acids for up here. These pKa's were between 40 to 50, okay, on sp3 and sp2 carbons. When you come down here, see the big drop? So that's the main comparison there. Remember, no eating in class. All right, so all I want you to take away from this is that if I have a hydrogen on a triple bond, it has some acidic character, okay? And since it's not a super strong acid, I'm going to need a decent base to remove that. So let's look at a decent base to remove that. The base that we use is NaNH2 to remove a triple bond hydrogen. Okay, and the name of this is what's called sodium amide. Okay. If you look at the structure of sodium amide, you have this here, where the lone pair is on the nitrogen. And when I have a lone pair on nitrogen, that's pretty basic. When I have the negative charge added to it, it makes it even a stronger base. Okay? So this thing here is a pretty strong base. Okay? And that's what we're going to use to remove that triple bond hydrogen. So now, if I react propyne with sodium amide, that nitrogen can now take that hydrogen and form our conjugate base there. Okay. So any questions on the use of sodium amide? Okay. I see a triple bond with a hydrogen, it takes it off. Okay. What about if I had a molecule like this here? What would be the product of that reaction? the product of that reaction. What does sodium amide want to do? Take away a triple bond hydrogen. Is there a triple bond hydrogen? So what's the answer?
There's
No reaction. Okay? So no hydrogen on the triple bond, so it's dead. Any questions on that? Well, if you look on your outline that you got, you get one after class if you came late. Numbers 2, 3, and 4 all go together. Okay? So we're going to look at number 3 here. And we'll call this heading here the use of the acetylide ion. Okay? What use does this have? Okay? The first use that we're going to look at is that of alkylation. Okay. So let's take a look at an acetylide ion that we've been using. That one there. And let's suppose we reacted that with this here. You may see what kind of reaction would happen there. What do you think, Red? What do you think?
With the chlorine, like substitute for maybe the.
What's this thing here gonna act as? Act as a base or a nucleophile. So if it acts as a nucleophile, where do you think it will attack? Where will it attack? Okay, not doing an elimination reaction. Want to do a substitution reaction.
The chlorine.
The chlorine.
It's going to attack the carbon that has the chlorine. Not going to attack the chlorine. Chlorine's the leaving group. It's not attacking the chlorine. Okay, so we added that alkyl group, which was an ethyl group, onto the triple bond. Okay. So see this? This is a way to lengthen the alkyne chain. See that? It's a way to make a longer alkyne. Okay. So let's look at a summary of kind of what we did here. So if we start with something like that, then we basically did 2 steps to get over there. One, react with sodium amide. And then secondly, reacted with the chloroethane. Okay, and that gave you this product here. Okay, so any questions how we kind of put that all together? Okay, let's see if we can work with this from another angle. Suppose you wanted to make that alkyne. What starting materials could you work with to get there? Can you dissect that molecule apart?
C.
Okay. What would be the starting alkyne here, where the H goes? Okay, so we got 2 sides, put that H. It's going to go on this side or that side. Okay, so we put it on that side. Okay, would that be helpful? Because then if I react with sodium amide, I get that as a nucleophile, which is a primary carbon, not a bulky. So it's a nice nucleophile. And then my substrate is that. Just put on a chlorine or some good leaving group. And we could get that there. Okay, so see how we can work backwards with these things.
Cyclohexane couldn't have been the substrate.
What's that?
The cyclohexane couldn't have been the substrate. Like if you were going the other way.
Yeah, if you did it the other way, yeah, then the cyclohexane would have a leaving group. That'd be a secondary. See that? So that'd be a, not as good as a primary one like that. Okay. So that's why we chose that side. Okay, so that's the first use of the acetylide ion, is to do alkylation reactions. Let's look at a second use. A second use is to C double bond O functional group. That's what's called the carbonyl functional group. Okay? I'm not going to get heavily into this, as this is covered more in 242, but since they have it in the book here, it's good to introduce it. Okay, so let's suppose we add a nucleophile. Let's choose this simple one here again. And now, let's react it with a molecule that has that C double bond O in it. Okay, how would this reaction here occur? Okay. Well, this C double bond O has a dipole moment. So we have these partial charges here. So where do you think the nucleophile would want to attack? The carbon with the delta plus. Okay. So the result of that is this molecule here. So you get that O minus, and then if you react that with H3O plus, you take one of those hydrogens,
I'm doing wonderful. How are you today? I'm doing pretty good. Great.
and you end up getting this alcohol. Okay. So again, I'm not going to get heavily into this reaction. It's a little bit more advanced than where we are right now. I just wanted to show it to you because the book shows it to you as well. Okay? Okay. Well, let's stop here for today, and I'll talk a little bit about the exam.